Howdy. Let's start off with this very sketchy picture. It is to represent, this is the Birkeland Current, and we have the auroral oval here. At the center of Earth might be this kind of pinch, hence a plasmoid. We have the Van Allen belts. And the Birkeland Current is flowing through Earth like this. We have this possible plasmoid at the center. So this yellow line here, if you would watch from above, it would be like this. That's why we have the auroral oval, which goes around. Basically, it's not really, there's always an opening to it, but it's round after all. We have the Markov convection, which separates different elements on different places on this. Yeah, let's call it for now tube, because the Birkeland current is in a way a tube. But we have hydrogen and oxygen here at the outer side. Neutral atoms of all elements will diffuse into the Birkeland current, but elements with the highest ionization values, hydrogen, oxygen, nitrogen, will be more likely to be found on the outer fringe on the BC. Elements with the lowest values of ionization voltage will be at the center. Yet another very sketchy picture. Just imagine that here in the center would be this plasmoid. So it would be a spherical structure and not a tube anymore, at least not in Earth's center. And we find hydrogen and oxygen here at the outer side of the Birkeland current, which might be the reason why we have the water on the outer side of the planet. A huge amount of the water might originate from Saturn back in the old days. So I think it's possible that due to Earth's composition and the size, which also goes back to magnetohydrodynamics, the distance of Earth and such things like that. But it might be just due to the size of our sphere called Earth that we have the abundance of water. It might produce it by itself, or it not produce, it's just, accumulates due to the fact that the sphere has the size it has. Might sound crazy? Maybe it is. But this is stuff I think about in my so-called free time. There isn't any free time. There are things that still are needed to explain and investigated. But now, why I talk about all these strange things, the reason is I think it was yesterday I read an article, or started to read, so now let's go into the article. We are at space.com. No asteroid impacts needed. Newborn Earth made its own water, study suggests. Published 1 day ago. Now let's refresh, maybe it changes into more days. But for the sake of truth, yeah, it's 1 day. It's from yesterday. We learned something new about our planet by looking at large data set of exoplanets. Earth, yeah, it's blue. There's water all over the place where you look. Clouds, oceans, all on the outer side. Contrary to popular theory that icy comets and asteroids delivered water to a dry newborn Earth, the planet itself may have produced its earlier water supply, a new study suggests. Yeah, like, if Earth grows until it reaches a certain size, there could be a possibility that there is less water because the spherical symmetry of the whole thing would not really anymore support this kind of surface water feature. But anyway, this water would have stemmed from chemical interactions between an atmosphere rich in hydrogen, which researchers think enveloped the young Earth and massive oceans of magma on the planet's surface. These conditions, water forms as a natural byproduct of all chemistry that takes place. Yeah, every chemical reaction is electrical in nature. But study co-author Anand Shahar, the scientists at the Carnegie Institution for Science in Washington, D.C., told Space.com. Planetary embryo. Yeah, let's go just through. I leave it up to you to think about that. Earth's uniqueness in the solar system is partially due to the abundant water that dominates over 70% of its surface, which is a lot more than any other planet in our cosmic neighborhood. Yet, when and where so much water came from remains an ongoing mystery from which scientists have not yet found a direct, conclusive answer. Listen to Walt Thornhill. He has a direct and conclusive answer to this. It's mainly from Saturn. One popular theory posits that asteroid impacts likely delivered most of the planet's water, but some research has shown that the water locked inside asteroids is chemically different from the water on Earth. Now, scientists say the abundant water supply that made Earth the watery world it is today arose thanks to a hydrogen-rich atmosphere early in the planet's history. Yeah, it's still hydrogen-rich. According to the latest study, homegrown water would be the outcome if the newborn proto-Earth was 0.2 to 0.3 times the planet's current size, slightly bigger than previously thought. Earth continues to grow, of course, accumulating more and more surrounding gas and dust. Yeah, maybe it grows from the inside out, like almost all things do. In that case, the young Earth would have been massive enough to hold onto its atmosphere for a long time, such that it would have been far richer in hydrogen than the trace amounts we see today. Earth's current atmosphere is 78% nitrogen. Hydrogen comprises just less than 1 part per million of the planet's protective blanket. Simply by changing the early conditions with which Earth formed, we are able to produce lots of water that goes both into the planet and into its atmosphere, Shahar told Space.com. Such hydrogen-rich atmospheres are regularly spotted around many newly formed rocky planets beyond our solar system. The most common types of exoplanets are super-Earth. Yeah, super-Earth. Maybe a place where people don't kill each other. This would be the super-Earth. But anyway, worlds bigger than Earth, but smaller than Neptune. Yeah. Now we are back to the size thing I tried to explain earlier. And the ice giant's smaller cousins called mini-Neptunes. Astronomers have previously found that the atmospheres of some of these planets have traces of water vapor, even on worlds that have high temperatures and pressures. Yeah, the sun. But anyway, glowing ball of water. Young exoplanets commonly host hydrogen-rich atmospheres during their first several million years of growth, Shahar said in a statement. Eventually these hydrogen envelopes dissipate, but they leave their fingerprints in the young planet's composition. Now, how they don't make the leap from like all other things grow in the solar system or even more far out, but Earth doesn't, you know. So rather than learning about exoplanets by studying Earth, Shahara's team reversed the norm by treating Earth as an exoplanet instead to understand its early years in a new way. Yeah, listen to Walt Thornhill once. Shahar. Maybe you would learn something. Tapping into the findings from exoplanet studies, the team simulated a hydrogen envelope around a young Earth and studied what that would mean for the planet's evolution. What we found is that simply treating Earth as an exoplanet surrounded by hydrogen, we were able to explain many of Earth's characteristics, including its water content. Sahar told Space.com. For the study, researchers developed a model to study 25 compounds and 18 different chemical reactions. They found that massive amounts of hydrogen from the atmosphere would have blended with the molten magma oceans on the surface below, which later solidified to form Earth's largest and thickest layer, the mantle. Yes, transmutation of the elements. The planet's abundant water stock then formed as a simple consequence of these chemical reactions, they found. Yeah, powered by the Barton current. The team says such movement of light hydrogen molecules from Earth's atmosphere into its molten interior early in this Earth's history answers two long-standing open questions. How large amounts of liquid water came to exist on Earth's surface, and why the planet's core, which is mostly iron, is less dense than what scientists think it should be. Yeah, it's a plasmoid. That's why it's less dense. But this is just what I think. We learned something new about our planet by looking at a large dataset of exoplanets, Sahar told Space.com. Answering the question from the lens of both Earth science and astronomy was the key. Now, really? I just remembered that my mountain water paper got published. I talk about water. Now I just realized that. Let's go over and have a look at it. I wanted to show you something. So now that's on page 87. The volcanoes are basically holes burned through the mantle by very strong electromagnetic discharge events, making the connection to deeper layers where we find magma and hot water. Even though the actual event is over, the energy exchange between ground and atmosphere continues. It doesn't have to be always a volcanic eruption. Very often we find that these spots influence weather patterns. Giovanni Gregori has done extensive work on the Earth-Sun connection theme. The following picture, figure 10, illustrates the continuous connection between ground and sky, which is therefore a circuit and will react immediately according to the environmental electromagnetic changes. The environmental changes Earth experiences are mainly driven by the Sun, and the Sun's environment changes accordingly to the changes in the connection to the center of the galaxy. There are also possibilities for having strong electromagnetic discharges, such as close cosmic encounters with other planets or asteroids which are big enough, as described by Immanuel Velikovsky. Many landscapes have been shaped by these events, but the evidence in terms of the creation of the Alps points more to the solar cycle. The planetary body interfering in cycles is actually a cosmic dust cloud, the cosmic current sheet, which triggers the solar micronova. Otherwise, the mechanics of massive discharge events between the heavens and the ground are basically the same. In the case of the Alps, I think the creation included a ground-to-cloud-to-ground discharge, like an arc. Lower atmospheric layers made a simultaneous discharge connection to the ground on northern Eifel and the southern side of the Alps, Campiville-Gray. It is estimated that Campiville-Gray had a major eruption approximately 36,000 years ago. This does not only fit well with sun cycles, but could also be a good indicator of the recurrent nature of these events. Like earlier mentioned, nature always seeks the path of least resistance and greatest conductivity. In pre-existing geological features have influence on the event, we might assume that Campiville-Gray was maybe already an existent pathway for energy, a Joule antenna, which got activated once again. The main driver for this is the Sun, so it is something which is recurrent. The location could differ next time. The 12,000-year cycle of the Sun is maybe the most influential of all the Sun cycles. A recurrent nova event. Not too long ago, mainstream science admitted that there are many other kinds of nova too. Not only supernova, but also micronova, like described in a recent paper. Our Sun is a star. There is no reason why it shouldn't behave like other stars do. We have volcanoes on both ends of the arc and a huge mountain range in the middle, under which lies strong geothermal activity. I think there are two kinds of ground-to-cloud-to-ground discharge events possible. One that burns holes on both ends and creates mountains in the middle, and the other one creates mountains on both ends and a hole in the middle. The hole might be a river system, lakes, geysers, or a volcano. In case of the Alps, we are probably looking at the first example. In order for an electric current to flow, it needs something conductive. Earth's mantle has a huge amount of water stored inside, much more than previously thought. If the environmental conditions are suitable, the water rises upwards, and since we have electric currents underground, water will eventually make and maintain the connection between the heavens and Earth. I think it is important to understand what maintaining the connection means, i.e. it is not it is only a good conductor, but water binds things together. E.g. a handful of dry sand is difficult to keep in your hand. It is almost impossible because it runs through your fingers. If the sand is wet, it sticks together and is even formable to some extent. This is where we should think about the importance of easy water. During the events which possibly created the Alps, loose material got sucked upwards in very strong electromagnetic currents, ionic winds. An event of this magnitude was likely to create the Alps. But I believe the evidence points to. These were mostly sediments that were in place from deposition, and something with a huge power pushed them up. Plate tectonic convection as a driver has been criticized a lot in the literature for not to have the power to do this, and many other contradictions. So there is a precedence for something else going on. The electromagnetic currents produce super strong winds. They can be supersonic and strongly ionized with wide variations. The water from inside the crust was making the connection upwards to the heavens and made other materials stick to it, like the water droplets in the sky, which catch all sorts of materials such as volcanic ash. Now let's scroll still a bit down. I think it's coming somewhere. Yeah, here. Check it out. Here on the left side we have the sun. And what you cannot see, these are like these filaments. And if they snap, there's a rope going through that. This is a NASA picture. So, here in the middle, where that thing starts, we might have the Alps. And on both sides of the arc, we have the Eifel and Campivillei. Comparison of an arc discharge event on the Sun and a theoretical counterpart on Earth. The form and shape of the discharge would match the scars on the surface of Earth's crust. But anyway, I will put a link below to the paper, you can read it. And there are like references here. Check them out. Yeah, water. Very interesting. Thank you. Bye.